Okay, this is the final review, Unit 1. It says to solve and graph. This first problem, though, you are only solving. Okay? So, who thinks they know what to do for example 1? Courtney.
Divide by 3.
Yes, okay, so we are going to reduce. So, what you need to do, though, is on the top, in order to divide by 3, 3 has to go into each of these numbers. Okay, so you might want to rewrite this as 24x over 3 plus 15 over 3 to remind yourself that 3 goes into each of those terms. Okay, so 24 divided by 3 makes, so we have 8x plus 5. And that cannot be reduced any further. That is your answer. Okay, example 2, these now we will be able to solve and graph. On example 2, who can tell me what the first step would be for this problem? Distribute is correct. So we're going to distribute the 7 to both terms. When I do that, I have 14x plus 35 minus, or maybe it's not minus. What you need to be careful of is when you distribute here, you're distributing a negative 6. So negative 6 times x is, and negative 6 times 8 is negative 48. Make sure you pay attention to that sign, because that's where people mess up, is they forget to take the negative to that second term. Is greater than 7. What's the one thing we need to remember with greater than and less than signs when solving? That's absolute values. What happens when you divide by a negative? Good. So you need to remember that whenever you divide or multiply by a negative, you flip the sign. So far we're good, but just pay attention. Okay, so my next step is going to be what? Combine like terms. Very good. 14x and negative 6x makes, and 35 and negative 48 makes?
Negative 7.
Nope. Negative 13. Good. Is greater than 7. Okay, next we add 13 to both sides. So now I have 8x is greater than 20. And my last step is to do what? Divide by 8 and reduce. Can 20 over 8 reduce?
Yes.
What can I reduce by? We can reduce by 4. Good. So I'm dividing by 4 to the top and the bottom. So I have x is greater than 5 over 2. How did I need to flip my sign here? No, it's only when the bottom number, the number you're dividing by, is a negative number. Okay, so that's my answer. And how would I graph that? What you need to be careful about is like your final's a multiple choice. Okay, so on your final they'd have like 0, 1, 2, 3, negative 1, negative 2. So where is 5 over 2 on that graph? Between 2 and 3, good, because 5 over 2 is the same thing as 2.5, right? So at 2.5 you have, would it be an open circle or a closed circle? Open, and closed would be if there is a equal sign, good. And then this is going to go to the right, because it's saying numbers that are greater than 5 over 2. So numbers to the right are greater than. Also remember that if your letter's on the left and your number is on the right, it's also like an arrow pointing right.
Wait, is closed circle of what?
Closed circle is if there was an equal sign underneath here. But since there's no equal sign. So if you wanted to make a little note, less than or greater than is your open, which is like that. And less than or equal to or greater than or equal to is a closed, which is where it's a circle filled in. All right, any questions right now on example 2? Okay. Example 3, we have an absolute value. Now, what do we need to remember with absolute values? Good, 2 equations, which is going to give you 2 answers. Okay? Now, what you also need to be careful of is that you want to first get the, very good, absolute value by itself. once the absolute value is by itself, if your answer is a negative, then the answer is going to be no solution unless it has, we'll just be careful. When it's negative, check your answer. If it is negative, check your answer. What I mean by that is, if it was like, absolute value of x equals -5, that answer would be what? No solution, right? If it was the absolute value of x is greater than -5. Well, if you remember, we talked about this. If you did like a positive is greater than a negative, is that true? Yeah, so that would be a true answer. If it said, or it'd be all solutions or all reals. But if it said the absolute value of x is less than -5, is a positive less than a negative? So that one would be no solution. Yes, do you guys remember that now? Okay, so basically if your answer is negative, you just want to check it, because it's either going to be no solution or all reals. Okay, only when it's a negative. Okay, so on example 3 is my absolute value by itself. So write your two equations. One equation will be 2x plus 4 equals 16, and the other will be 2x plus 4 equals -16. And then you solve both of those. So we subtract 4. 2x equals 12. Divide by 2, and we get x equals 6. For my other one, I subtract 4 to both sides. 2x equals -20. Divide by 2, and x equals -10. No, you can have, the thing is that if you plugged -10 in here, you would have 2 times -10, which is -20, and -20 plus 4 is -16, and then the absolute value of -16 is 16. So you can have a negative number in here, but when it comes out, once you simplify, it'll end up being a positive. Okay, you just can't have a negative on the outside in the original problem. Okay, so there's always two answers, because we can have a negative in here, but when it comes out, it'll end up being a positive. Do we have other questions on example 3? Okay, example 4. What is my absolute value by itself? Before dividing by 2, what should I do first? Good, subtract 1 to both sides. So I have 2 absolute value of x plus 4 is greater than 10. What would be my next step? Divide by 2. So I have absolute value of x plus 4 is greater than 5. At this point, remember how we have and or problems? Who remembers what kind of problem this is? Or, great or. This is an or problem. Okay? So that means you have 2 separate problems, or two separate answers. When you have an and, it's when you write it as a single statement. Okay? So this is an or, so we're going to have 2 separate answers. How will I write my 2 equations right now? X plus 4 is greater than 5. What happens when I do the negative? Good, less than -5. Okay? So we have 2 equations. Remember that when you do the negative, you flip that sign. Okay? So now we come over here, we subtract 4 to both sides. And I have x is greater than 1. Over here I subtract 4, and we have x is less than -9. And this is an or problem. Okay, when we go to the graph, you would have a 1, or sorry, you'd have a -9 and a 1. At -9, is it open or closed? Open going left, okay? And at 1, is it open or closed? Open going to the right. Okay? So both of those are your answers. This is the answer, and also your graph is the answer. Questions before we move on to 5? Okay, example 5. Is the absolute value by itself? Yes. Once it's by itself, you decide. Is this an and or an or problem? Good. This is an and because it's less than is and. Okay? Now we can write our 2 equations. What is my first equation? Just what it already is. 2x plus 1 is less than 13. And what's my second equation? Perfect. Good job, you guys. Okay, so we flip our sign when we have the negative. And then now we solve these. Here I subtract 1 to both sides. 2x is less than 12. Divide by 2 to both sides. And we have x is less than 6. Over here, subtract 1 to both sides. 2x is greater than negative 14. Divide by 2. Am I going to flip my sign on this one? No, because I'm dividing by a 2. It's only if this number on the bottom that I'm dividing by is a negative. So it's still x is greater than negative 7. Okay? Now this is an and where we have to write it as a single statement. Sometimes graphing it helps you write your single statement. So if I make my graph over here, I have negative 7 and a positive 6. At negative 7, is it open or closed? Open, and it's going to the right. At 6, it's open, going to the left. With and problems, your answers where they overlap, and here they overlap in the middle. Who remembers how to write this as a single statement? Good. Negative 7 is less than x is less than 6. If you start with your smallest number, negative 7 is smaller than 6, and you go in order that way, it'll always be the and sign, your less than sign from the beginning. Any questions there?